Okay, I'll start the next point. This is the last point from your this course, object-oriented programming. Right? Uh, till today, we have seen the programming concepts related to the object-oriented programming. But today, we are just moving toward the point which is not related to programming. This is related to presentation, we can say. So, suppose you are a programmer, you just completed your project and you want to present your project to the non-programmer, we can say. So in that case, how you can present your project to the non-programmer person, or consider that manager is there and he's just wanted to understand your project in short. He's not interested in your programming, he's not interested what you did in your programming or everything. So in that case, we need to use one kind of presentation, and that presentation is nothing but this the in UML presentation, we can say. So that is a unified modeling language. This is a language, but they in your course, as this is mainly the object oriented course, so we will not go through the complete language. We have only so these three diagrams here. So with these three diagrams, we'll try to represent our project. Okay, so how do we represent? That is the main thing here. So to represent your projects, we are having these three kinds of diagrams. Using these diagrams, we can represent our project. So in the UML, or we can say unified modeling language, so this is a graphical way of representation, we can say. So here I'll just tell you something about this. So UML stands for unified modeling language, that you know. So it is a visual language, as I said, to represent any programming concept through the non-programming way. So we can have one kind of presentation, and that presentation is this UML presentation. So this is a kind of graphical, or we can say visual way. So it is an industry standard graphical language, we can say, for specifying whatever the concepts we have. So to specify these concepts, to visualize, to construct, or for the documentation the artifact of the system. So whatever the system we have, to represent or to explain the specification of that the system, or to visualize what that system is, or how it is been constructed, or what kind of documentation we have. So to represent all these things, we need the way of representation, and this is the way of representation, we can say. So UML mostly uses graphical notation to express object-oriented analysis and design of the software. So as I said, this is the visual language, so it uses some graphical notations to express the object-oriented analysis and design of the software. So it simplifies the complex process of the software design. So whatever the software design that we know, so that software design is very complex, and if you are representing that software design to the non-programmer, so it's very tough for that person to understand that concept. So how we can explain or represent that complex concept to the non-programmer? So that way is we have this the UML the representation. So here in this the UML modeling, so we are having three diagrams in our syllabus, we can say. So with these three diagrams, we can represent our project. Now consider here, so you are having project in your hand, you just implemented one project. In that project, you just use some classes, objects, some the features you just applied for that, like the which data is protected, which data is public, which is private, or the whatever the implementation, the loops you just use. All these things, suppose you are having there in your project, but now whatever is that programming concept you need to represent. So how do we represent that project to the third person, or to the manager, we can say? So that thing we'll see here, right? Now you can consider any example, because till this we have studied the class and object concept, so we'll just mostly focus on that class and object concept, right? So if you are having, suppose, one simple program of inheritance, so in the inheritance one, there is a one, suppose, base class, one derived class is there. It means we have two classes, and for these two classes we create the objects and we access the functions, right? So these things we know, but being a programmer we know these things. If suppose you want to represent that the concept to the third person, so it's very difficult to explain if that third person is not having the knowledge about the programming, right? So how do we represent? So first thing is we can use that class diagram concept, second is object diagram concept, and third one is a use case diagram concept. So these three concepts I'll just tell you. And uh, if you are having any program in your hand, so for that program how to represent using this class diagram, object diagram, or suppose the use case diagram, that you need to know. Okay. So first we'll just move toward the first one. Before this, I'll just that UML is divided into three parts. So here I'll just tell you these three parts: structural modeling, behavioral modeling, and architectural modeling. So in this, these first one, structure modeling, represent the static features of the system. So whatever the system we have, so this structural modeling represent the static features of that system. Behavioral modeling, that represent the dynamic features of the system, and last one, that name indicates, that architectural, it's a blueprint of the entire system. It's the architecture of that entire system that we can see. Now whatever is the class diagram and object diagram, that comes under the structural behavior, and that use case diagrams comes under the behavioral, the modeling, right? So we'll see the first one, that is a class diagram. Now what that class diagram is, we know, if you are implementing any program or any project, so first thing that comes in our mind is, that is the class, right? So we write the class, we create the object for that class, and using these objects we can access the member functions of that class. So this is the normal, the process that we know when we just implement any program, right? So for this class diagram shows the classes of the system. So as I said, if you are having one program, that is a, suppose, the student database program in your hand, and you need to represent that using class diagram. So it shows the classes of the system. Means whatever the program you are having, for that, using this class diagram, we can represent the classes of that program or that system. And again, there are interrelationships. So whatever, if suppose the more than one classes are there, then what is the interrelationship between these, the multiple classes, that again we need to represent here. And whatever the operations and attributes of the class. So operations means normally we use the member function in the class, so these are the, we consider as the operations, and attributes, it means whatever the data we consider into that class, so that we consider the attributes. Okay. So here means it shows the classes of the system, their interrelationships, the operations, and the attributes of the classes. Okay. Now it explores the domain concept in the form of domain model. Right? So it analyzes requirements of the form of conceptual or analysis model, and also it depict the detailed design of object oriented or object based software. So what that when we'll just show you that example, so that you will understand these things. Now see, one thing we just understand here, suppose one consider one example, you are having that class student database program, right? So we'll try to write that diagram for that student database class. So in student database class, whenever we just start to implement that program, so we create first class, then in that class some data related to that student, like that name would be there, class would be there, that roll number, right? So year and something, so whatever that data we want to implement, so that we can put into that class. That is one thing. Second, first is the class name, then second is the data, and then whatever the operations we need to perform on that class, like create the database, or if you want to perform the sorting operation on the student database, if you want to insert any data into that student database, or you want to delete any data from that student database. So whatever are the operations you want to perform on that, so we perform on that the class, right? So this example you just consider in your mind so that you will understand that class concept. Okay. Now see, whenever just we go for the representation of this class diagram, so for first thing you need to know the name of the class. Second, whatever are the attributes required for that class, and third one is the operations required to that class. So these three things you need to know before just representing your class using this class diagram, right? So here if you see, as I said, this is the way of representation of your class diagram, right? You can see here. So what is represented in first block is that is for the class name, right? So if you are having student database class, so that class name is suppose student, so that class name is student. Then class attributes like that, name of the student, roll number of the student, then batch, year, address, whatever the data we need to use for that class, so that we can consider as a class attributes. Okay. Now class operations, so whatever the operations you need to perform on that, so these operations we can mention here. It means when we have this thing in your mind, and when you just represent that program using this class diagram, so third person will understand what that class name is, what that class name is, what are the class attributes, and what are the operations are there on this class. So these things will understand that third person or your manager or whatever your customer, whenever you have the class diagram of your project. Okay. Now this is the structure of this class diagram, right? Now when we just go into detail, when we just have one example, so which are the attribute, what are the operation, what would be the class name. So with this we can understand here, actually here that class name must be a student. Here that the mistake, I have not corrected this one. So right here this, okay, I'll just correct it afterward. But consider here, this is the student that we are considering, that class name is student here. And in that student, that attributes we have, suppose only two attributes, multiple attributes you can consider. But for example, consider only two attributes are there. One is the name of student and second one is the roll number, right? And the operations which we are performing here, suppose one operation is there, that is the create record simply, right? Multiple operation you can represent here, but consider here in your project only one operation is there, right? But now see, again this we cannot say that this is the final representation of your class diagram, because the class name is okay, that class name, but whatever is the attributes, whatever are the attributes which is represented here, so these are not having the detailed meaning of this. Like I don't know this, the name data type is what, the roll number data type is what, that I am not getting anything from this representation. Again, whatever are the data types or return types for this the operation, I am not getting anything. So again I need to put these thing into this diagram. So if you see here, again you are going into detail. Now see here again, that same thing you just consider here, a class is your student, right? Now here with this, little bit we have represented in detail, like name, the type is string, that roll number type is int, and whatever is this operation we are performing, its return type is integer again. So this thing we understood from this one, but again we cannot say okay this is a complete class diagram, because whenever we just go with the class, if you are suppose implementing that class, now in that case we need to know which data is private, which data is public, which data is protected, right? So here some the relationships are there, so we need some symbols for the representation of these public, protected and private, right? So how I can represent this? So see, here some relationships are there, or I'll just show you how we can represent that data. So data is public, private or protected, right? So you can see here visibility notations I just use here. So you can use that plus for the public, minus for the private, and hash for the protected. Now we considered here, right? We consider here that plus is for the public. It means the name is public. Okay, name is public. Then roll number is the private, and that return type of that operation is the protected. That is just I have assumed here. Okay, but whatever the things in your project or in your program, these things you can understand. And see, if suppose in your exam, final exam, suppose they have given any the example, and if they say ki, draw the class diagram for that example, then you need to put whatever the visibility notation you just use into that. So these notation you need to consider over here. Okay, so yeah, here you just understand, to represent the data public, we can use the plus notation. For the private, we can use minus notation, and for the protected, we can use the hash notation. So it means this is the complete diagram, you can say, right? So whatever is the last diagram, this diagram is a complete diagram for the program, that is a class, sorry, student database, right? So using this one, you can represent that student database diagram, that class diagram, right? But see, if you are having only single class, in that case it is okay, you are suppose representing that class diagram with this. But if you are having multiple classes in your project or in your program, then we can represent that class diagram for these multiple the class, for the need multiple class, with the same notations or whatever is the diagram we have just used here. So that same concept you can use for the multiple classes in your project. But suppose the multiple classes are there, it means multiple the class diagrams are there, and you need to represent the relationships between these classes. Because if in your project multiple classes are there, so they need to have some kind of relationship with each other. Now, what kind of relationships these classes will have? Again, to represent that relationships, we have some kind of relationships, right? So, if you see here, these are the five relationships between the classes are there. So, if you are having suppose the multiple classes, so we can use these relationship between the classes to represent the relationships. Right? So here, first one is the association, dependency, aggregation, composition, and generalization. So I'll tell you these relationships with examples so that you can represent that class diagram using these relationships if you are having multiple classes. Right? Now suppose first one is the association. Now see, consider you have the two classes. One is the teacher class and second one is the student class. Right? So to represent that association between this student and teacher class, we need this solid line. This is the one thing. You need that solid line to connect these teacher class and student class. This is one thing. Second thing, see this solid line is not having any kind of arrow from either, not from teacher to student or teacher student to teacher. There is no any arrow. So this arrow is only labeled with teachers to, right? So if you read this, if suppose consider this arrow is not here, so we can read the teacher teaches to student. This is one, or student teaches to teacher, because this solid line is not having any arrow. So to maintain the flow, we need to use this kind of arrow here. It means this is in this direction. So teacher teaches to student. This is one thing. Now again, some notations we have here in this box. I have just shown some relations notations. So it means, see here, one represent that is a single teacher. It means there is a single the class entity, right? And here one dot dot star means multiple students are there. So if you see here, so one means single class, 0 dot dot 1 means 0 or 1 class, 0 dot dot star means 0 or more classes, one dot dot star means one or more classes, or exact number we can say like one or two or three, four, five, something. These are the exact numbers, right? Now here in the associations, so teacher teaches to student means one teacher teaches to multiple students. So this is one the relationship between, or this is one way of the representation of that relationship between two classes. So teacher class and student class, right? This is the association. Now second one is the dependency. Now here the dependency relationship between the two classes we represent using this dotted line, right? So we represent this using dotted line. So one class you can consider as a customer class, and second one is the supplier class. So this dotted line represents that supplier class is dependent on the customer class, right? So this is the way of representation of this dependency relationship between these two classes. So if you are having two classes like customer and supplier. Now second is aggregation. So here we can see this kind of diamond is used to represent this aggregation relationship between two classes. That example is given here. So library is one class and second one is the book, that is a class. So here we considered that library is a container class and book is a contained class. So container class means what? Whatever is this contained class, that is belonging to the container class. It means if you see the example of that library, so in that library multiple books are there, right? So that library contains the books. So that's why that library we consider as a container class and book we consider as a contained class, right? So that you just understand the concept. And here again that relationship we have shown here. You can see here one dot dot star means multiple books are there, right? And this is the way of representation of this aggregation relationship between the library and book class. But here, one thing you need to understand here, I have written here. So here, book class is not strongly dependent on the library class. That is, content class is not strongly dependent on the container class. So this is the thing into this, that why we are saying this, that book class is not strongly dependent on the library class. That reason is not necessary we can keep only that books in the library. We can keep these books in our on table in our home, in our office, or anywhere we can keep the books. It's not mandatory only to have that book into the library only. So that's why we are saying that book class is not strongly dependent on the library class, right? This is the thing here in the aggregation. Have you understood this? So library is a one class, book is a second class. Library we consider as a container class, and that book is contained class. And these two we can represent using this. This is an empty diamond, na? That you understand here. And this contained class is not strongly dependent on the container class. Now next one is the composition. It is same, or we can say similar to your this aggregation class. Only here this empty diamond is there. If you see here, so this is a field diamond. Rest things are same. You can say one example that I just shown here: school bag and bag pockets, right? So these are the two classes. One is what? This is a school bag. Second one is the bag pockets. It means again here, this is a container class and this is the contained class, right? Means what? That school bag is having multiple pockets. So that's why we said that school bag is a container class and this is a contained class. But in this composition relationships, so that container, this contained class is strongly dependent on the container class. Actually here, this is a typing mistake. What I written here is a contained class has strongly dependence on the contained class. That same thing I have written. But you just understand here. So this is the contained class and this is a container class. So we can say this bag pocket class is strongly dependent on the school bag class. It means if I destroy, suppose, the school bag, automatically the pockets will be destroyed, because these are very strongly connected to the school bag, right? So that's why we said this back pocket is strongly dependent on the school bag, right? So here, so it is, as I said, it is like aggregation except this one. This is a field diamond, and there is a strong dependency, we can say. That's it, right? This is about the composition relationships. So you just understand, simply here I am showing this class with this the rectangle, but actually this is not rectangle, this is a complete the class diagram, right? And then you need to represent these class diagrams with these relationships. Now last one is the generalization class or that relationships. So here, specialize and generalize the ways are here. So example is given here, support teacher, person, teacher and student, right? Now if you just go from bottom to top, that we can say that is a generalize, and when we go from top to bottom, then we can say this is a specialized. How it would be? If you are going from bottom to top, it means first you are starting teacher and then to going to the person. It means here every person, sorry, the teacher can be a person, means the teacher is a person also, that is the thing, right? But every person cannot, we can say teacher, right? So that's why if you are going from bottom to top, so it means this is a generalized, and if you are going from top to bottom, so whatever the this part, this we can say specialize, or this we can say specialize if you go from top to bottom. So if suppose these kind of classes are there and this kind of relationship is there, then you can show in this way, right? So one example I'll just show you here. You can see here. So customer is one class, order, special offer and normal. Sorry, special order and normal order. Here, as I said, as the this is a one class, so it has some attributes and operations also. Again, same. These classes have attributes and the operations along with the class name. Right. Only here, just think about these arrow. You can see from bottom to top you are going, it means this is a base class kind of, and these are the child classes. So this arrow is having this kind of, this one, right? And here from n to 1, right? Orders are many but customer is one, that kind of. So in this way we can represent your the class diagram for any project or for any program, right? So if anything you can ask me, right? So in this way you can represent and see here, there is no any relationship of the programming concept or something. This is a totally non-programming way, but to represent this one you need to know that programming, right? Otherwise I'll just go for the next one, that is a object diagram, because when we have a class, then for that class we create the object, right? So again, we need to know the object diagram for that particular class, right? So it shows instances instead of classes. So in last one we have seen the classes, but here instead of classes we, it shows means that object diagram shows that instances means objects instead of classes. So they are useful for exploring small pieces with complicated relationships, especially recursive relationships, right? So again here, whenever we just go with the object, so first you need to know that that from which, for which class that object is been created. That you need to know, right? So it means whatever is that class name, that would be the, we can say that type of that object, right? So here the simple way is there to represent that object diagram. You can see here, object name, this is whatever the object we create, this colon and then that class name. If you are saying suppose that student class is there, then that for that student we can create s or s1 s2 s3 something object, and that class name is a student. And attributes are here, only you need to specify these attributes, because in class diagram we just specified only type of these attributes. Here you need to specify the actual input of the attributes. So if you see this, you can see here S1 is the object, student is a class, and you can see here this is a name. I'm not showing here a type of that name. That name actually you need to write there, and along with this the visibility mode. So plus is public and that minus is private. Roll number, you need to put that roll number here. And suppose if you don't know that object for that class or the any class, so you can represent that object diagram using this. So simply colon and that class name, this is called as anonymous object. Okay, so this is very simple way to represent that object class. So if you are having one class diagram, for that class diagram you can draw the object diagram. So this is very simple, right? It means if you are having program knowledge, or if that program is with you, then it's very simple to draw the object diagram and class diagram, right? So example also I'll show you here, right? So these are the instances. We can say this department is a class, and this is object math statistic, then department statistic, department math, department applied math, and department math education, right? So in this way you can represent here only. And the second block you need to specify the input to the respective attributes. Okay, so this is about the object diagram. So we have seen the class diagram and object diagram. If anything you can ask in next lecture. I'll just tell you about the use case diagram. That is the important one. And see, based on this, either class diagram, object diagram, or the use case diagram, there would be a at least in one question in your final exam. Okay. So if anything you can ask.
Hello, sir.
Yes, yes.
Sir, how we are going to identify the relationship between the classes? Means we are having 4 to 5 types. So how we are going to identify which type is exists between two class?
Now see, this is not the kind of identification, huh? Because being a programmer, you need to know what kind of relationship would be there between these two classes, right? And you need to decide, being a programmer, what kind of relationship would be there between two classes. So there is no fixed relationship we can say, because if you are implementing one the project, right, and you implemented as per your customer needs, and same project suppose I have implemented with the my customer need, so that relationship would be different. Getting my point?
Yes, sir. Got it.
Ah.
Thank you, sir.
So you if you are having that project in your hand, so you need to know what kind of relationship would be there, right? So one see, uh, 1 minute. Ah. If you see this one, this diagram, is it visible? This
Yes,
class
sir.
diagram. Ah. Now see, here I just told you this is about the generalization. Got it? But I cannot say only that generalization relationship is there in this diagram, because teacher, person, student, these are the different classes, and might be that student and teacher is having some kind of relationship, or teacher again having some kind of relationship with student, or we can say these either teacher or student will have some kind of relationship with the person. Getting this? So not only ki in these three classes only this relationship is exist. Getting my point? It is depend on your need. You can they decide which kind of relationship would be there. Because see, one example I just shown you here. You can see here teacher and student, right? So here I just told you this example under this association. Now the same the teacher and student that class is here into this, but they I told you the in different way, because here one more class which is added, that is a person. That's why it is going into the another relationship. But that you decide which kind of relationship is there when you just implement your program, right? Any other? Any other doubt?